Hello coders, today we're going to be talking about testing to break. I'm joined here by Rob Waller. Rob is a speaker, developer. He's also been on CNN. Rob, how are you doing? How's your week been?
I'm doing very well. I've had a good week. Me and my partner are looking for a new house, and so it's been lots of rushing around looking at houses, pulling our hair out.
Wow.
But it's been a good week.
No way. Can I ask whereabouts you're looking? Is it in the UK?
In the UK, outside of London. We're making the move away from London, out to the countryside somewhere.
Nice. Are you based in London at the moment?
Yeah, in Ealing.
In Ealing? Nice.
So West London, yeah.
Very nice. Very, very nice. Now, you've been on CNN. Can I ask you quickly, before we get into the testing stuff, about that? What was that all about?
Well, it had nothing to do with criminal activity or hacking, which was good. But basically, I think it must have been, it's a long time ago now, and this is making me feel old. It was about 8 years ago. I set up a sort of startup in the sort of social media marketing space, doing sort of analytics work, and because there's a lot going on in that space at the time. And basically, one weekend, I built this little Twitter app, I suppose you'd call it. It did Twitter analysis, and it told you how many fake followers you had.
Oh, wow.
So basically, like, it would assess your account and show that you've got like 30% of your followers are fake, or you've bought them, right?
Right.
And loads of sort of, B, C, D, E, F list celebrities have been buying these followers to make themselves look more popular.
Okay.
And journalists had started looking into it, but it was like quite a manual process.
Right.
And I just thought, my background, which had been in email marketing, I'd done a lot of list management work. I was just like, this is just list management work. So I wrote a quick algorithm and then put it online.
Right.
And basically, not much happened. I shared it with a few journalists, and they had a play with it, and they were like, oh, this is nice. And then one Tuesday or Wednesday or something, someone at Mashable picked it up. And this was just before the Obama-Romney election. And they ran Obama versus Romney through it, and then did an article on it.
Oh, wow.
And then it went completely bonkers. I learned DevOps in about a week after that, because I had it on like a shared host.
Oh, gosh.
And I had to then build my own like VPS and all this stuff before AWS was really a big thing.
Wow.
And then, and then just got invited on CNN to talk about it. It was really weird.
That is so cool.
Yeah. Just mad.
Wow. Oh gosh. So you went viral.
I did. Yeah. It was crazy. Yeah. I went from like a few hits a day to like 30,000 an hour.
Wow.
It was. I learned a lot about coding in a very short period of time.
Yeah, I can imagine. Wow, I can imagine. Well, hats off to you. That's quite a thing to your name. Awesome.
It was good fun.
Yeah. So you've done a series of talks recently. One in London, PHP UK, on test to break. You've also done that at PHP Southwest. Unfortunately, I wasn't there. I was super busy doing other things. However, I have seen the talk at PHP London. I saw that on the old YouTubes. I think you've heard of YouTube. Yeah, I'll put a link to the talk in the show notes as well. It's a fascinating topic, testing to break. Can you talk about what testing to break actually means?
Well, I mean, test to break is kind of a sort of term I sort of came up with,
right?
Because I quite like the term.
Yeah.
Other testers might refer to it as sort of negative testing, where you're deliberately trying to write a test that sort of either your aim is to break your application or put it in an unusual situation.
Right.
The best way to look at this is to think of it as very similar to what an organization called NCAP do, which is the new car assessment program.
Right.
And basically, you get those like 4 or 5 stars on your car when you buy it, and it tells you how safe it is.
Right.
Or NCAP are basically doing a form of test to break, but with cars. Like they drive them into walls at 30 miles an hour and see what happens. Like, does everyone die, basically?
Quite an important test. Yeah.
Yeah. So they're trying to put the car in an unusual situation and see if it basically, like, if you were to put it in like coding terms, like fails gracefully, like airbags deployed, the seatbelt tightens, and like even though this car's crashing, like it's still sort of working and not like it doesn't burst into a ball of flames. And like that's what you want to have. Like if something goes wrong with you, you basically don't want your code to burst into a ball of flames either, do you? So
I guess not.
It's kind of trying to do that with code rather than a car. Does that make sense?
Yeah, it does. It does in a way. You're trying to test for the unexpected, and I guess whenever we write code, we are assuming, or at least I do anyway, I assume that users are going to use the code in the way that I wrote the code. So, this is the feature, and you're going to use that feature as the feature was intended. But a lot of the time, users will use it in a very weird way.
Yeah, absolutely.
Or they'll access your feature from a very different obscure path into the application. And therefore, perhaps their account has had some impact or influence upon a different feature, or that feature has impacted that user account. And so when they get to your feature, it's in a completely different state to what you had originally intended. So yeah, no, I dig that. I get that. But from there's many different types of testing. Is this just for unit testing, or is this for functional testing, or is it for all types of testing?
I mean, I would say the principle applies to any type of test. So, a QAs do this kind of quite a lot, actually. Mm-hmm. You get, say, for instance, you've got a form and you've got an integer field on it. Yeah. I don't know, like age in years or whatever. Uh-huh. And a good QA will come along and just type 9999999999999 in, right? And see what happens when you throw a big int in there, or -1 or something like that.
Okay.
So like QAs have probably been doing this sort of testing like for a lot longer than maybe developers have thought about it. Like this idea of like writing specific, say, unit or integration tests that are like, okay, so what happens if I ask this difficult question of my code?
Right.
Like, throw a big int at it, or do something that doesn't seem logical given the way I've written the code.
Okay. So in your opinion, what would you define as a unit test compared to the other types of testing? Do you have some rules that you define as, say, a unit test can't, work on a database? A unit test must be small compared to the other types of stuff. Functional testing, perhaps, is testing the business logic. Do you have any of those kind of things that you work with on a day-to-day basis?
Yeah, I mean, obviously it's just my opinion, and different developers will have their own opinions. Mine, I like to keep unit tests focused on business logic.
Right.
And what I try to avoid with unit tests, and you can't do this completely, is you try and avoid input-output stuff. So maybe interacting with a file system or interacting with database and things like that, because when you get into that area, it becomes a bit messy with unit tests, and you end up having to do lots of mocks or stubs and things like that.
So you're not talking here about, when you say input-output, you're not talking about, say, making sure that a value is set after, say, you've injected it. It's more to do with the input. It's more to do with perhaps the input of going into the file system, like you mentioned, or going into the database, or using another dependency. Yeah. Okay, that makes sense.
Yeah, it's exactly it's that sort of stuff. And because I would say once you start dealing with, because you should test that bit, the input output, like handling a database request or calling the file system. But you've wandered into sort of what I call integration tests, and then functional tests are obviously looking at things like maybe an API endpoint that's exposed to a user or a client or what have you. I think if you focus your unit tests on business logic only, they become much easier to write.
Right.
And it will also hopefully result in better code, because ideally, like your business logic, the stuff that is like processing data and making decisions about in your application, it shouldn't care where data came from or where it's going.
That's true. Yes,
so
that's
like
true.
If the data came from the database and is going to the file system, or vice versa, your business logic doesn't care about that. It just gets a collection of data, does some processing on it, and then passes it on to whoever needs it.
I dig that.
Does that make sense?
Yeah, I dig that. I certainly get that. I guess, I mean, you could, for instance, decide one day to change your database, or change the type of file system that you're using. Maybe it's S3 one day, maybe it's something else another, and you removing that coupling from the unit test. So making the test just test the smallest thing and not worrying about where that thing actually lives means that test in itself is quite reusable in other contexts. Yeah.
Absolutely, I agree.
I definitely dig that. I must say that when I started unit testing a long time ago, and I'm certainly not, I don't test all the time, unfortunately. But when I started, I mixed and matched everything together, and it was like this one big mess of functional integration and unit tests all in one massive thing. And it got to say 30, 40, 50 tests, and then suddenly the system would just lock down because it would be trying to, run the browser and add and stuff to the database and remove things from the database to clean up the test and tear it all down. And I thought what I was doing was really, really awesome, and then it suddenly just locked up. And then I discovered what perhaps these unit tests should actually be, and then it's a very weird process of breaking down an application into testing a singular thing, because it's quite difficult when you've got a very complicated application, as most applications are complicated. Breaking them down into small little modular components to the nth degree to test that one thing can actually be quite difficult. And I found that testing often means that I have to restructure my application because my application isn't testable. Yeah. Okay, so going back to the test to break. So this is negative testing. This is testing for things that that these are unusual things. So when should one do this? Should they do this before you develop the code as in a TDD approach, or should you do this afterwards, or does it really matter?
I mean, theoretically, you can do it before, but I think this sort of wanders into the topic of the difference between test to break and test to work.
Right.
And that when you're following TDD and writing tests first, you tend to write tests that prove your logic works.
Yes.
If that makes sense.
Yes.
And you might with my approach to testing, I tend to do 2 sweeps of my code.
Okay.
So the first bit is the test to work bit, where I write some tests to get the thing working.
Mm-hmm.
Yeah.
Mm-hmm.
And obviously this goes with the sort of red-green refactor approach.
Mm-hmm.
But my second round of tests are the tests that try to break my logic.
Right.
And some people use the term triangulation, I've heard.
Okay.
But it's not really triangulation.
I've not heard that.
It's an approach where you're not quite sure what the answer should be, so you write a few tests to slowly work out what the answer should be.
Oh, right. Okay. Yeah.
But I would see test to break as slightly different, and I would see test to break as a sort of secondary process.
Right.
That you've got your code working, and then you're going, okay, so I've got this code working, and it looks quite nice, and everything's good. Can I think of any scenarios or any tests I could write that would go, okay, this might be what some random user might input, or like, could this approach end up in a result I don't want, if that makes sense?
I see. Yeah. It's the driving the car into a tree type scenario, isn't it?
Yeah. It's like, cars are meant to be on the road and driving forward and everything's great, but sometimes they'll hit an object. What happens when they hit the object?
Yeah, I guess this is very important for anyone who's writing software for Tesla.
Yeah. Well, and it's the same for anything, like, say a big bank, anything that's like of importance.
Yeah.
I mean, I've spent a lot of my career in the sort of marketing space, I suppose, and ad agencies and what have you, digital agencies, and maybe the work there isn't so, it's not fundamental to the well-running of this country or what have you. But some developers are working on stuff that for banks or for the government and various other things. And even like Google, these organizations, are important and we want their stuff to work. So like test to break becomes even more important in those areas, if that makes sense.
Yeah, I see. Can you give me, apart from the car scenario and the bank, is there any other examples that you can give where you're comparing a test to work versus a test to break?
I love the car scenario. I mean, it's just so easy. I mean, I see it as because it's about the thing about test to work is it's like with standard inputs. I like the term with standard inputs.
Sure.
So I'm going to use a standard input with this system, what I'd expect, and then what I expect back. And you can see this as like with the car ignition. So like you will do some tests with a valid key. So you've got a car key and you'll test the ignition and make sure the engine starts with a valid key. Right. And then you'll go, okay, I've got an invalid key. I'll test that, make sure the engine doesn't start.
Yeah.
There's still valid standard inputs, just one is to work with this car and one is not to work with this car.
That is a very important test. Yes.
And that's test to work, right? So you're going, okay, the next one would be like sticking some sort of foreign object into the ignition and seeing if it could work, right?
I guess like a screwdriver or something,
a screwdriver. Or in a modern car with these sort of like, I don't know, these RFID keys or whatever they are. Like you might just, can someone start the car using their laptop or something or their phone, right?
Sure.
That's not meant to. Can it be hacked? And the car industry had a problem with this because obviously lots of cars have been stolen recently because of the dodgy keys, So they're not always doing test to break in the car industry. There are things they're missing, but like I think that's a good explanation of it. Like it's with standard inputs. So you start writing your test with like your standard input that you expect to work, and then you might go, okay, I don't know. So say for instance you're doing some sort of number-based range logic, and your range is if I have 10 to 20, I expect standard functionality to occur, and then you might write a test, going, okay, well, what happens? 0 will be a valid integer, so I'll pass 0 in. What happens? Does the code just something weird happen, or maybe like passing 100? What happens with 100? Is my code going to work in one way? That makes sense.
I guess. Speaking from my experience, I've rarely done test to break. I will write code, test the code, or I'll test the code, then write the code, then test the code. And then when it's acceptable, when I get the green thing, I move on. That's good. I'll move on. But I think test to break is actually it's an interesting and important, I feel, way of just double checking and making sure. For me, especially when I write code, I'm thinking about the logical flows of how things should be, and I'm writing them to those procedures and those functions and those routines. And anything else that is outside of that, I don't think about because I don't need to think about it because I'm writing the code for it to work. So this is a bit of a mind shift to go, okay, so I've now got this code. How can it be used in a way that isn't intended and isn't expected, and what will happen? I love the examples that you had on your talk where you were doing testing against exceptions, and checking for values and stuff, because that's very, very important. So how about legacy applications though? How would you approach this with a legacy application if, say, for example, you were given this monolithic app and you were asked to write a feature, how would you test to break against something that you haven't already written, or you're adding a feature to something that you don't own, and you're trying to test to break not only your stuff but maybe the other things underneath? Is there any tips that you've got for that?
I mean, that is difficult, and I've worked on quite a few legacy applications, and it can be difficult to know where to get started with testing, because you have that problem a lot of the time of, okay, if I want to be able to test this, I'm going to have to rewrite some of the code. And one of the obvious problems people tend to have is your long methods. So methods with 20 plus, maybe 30, 40, 50 lines of code. And those methods will have lots of paths running through them. So you obviously can't write one or two tests and go, oh, well, this code is tested, because it might have, 10 or 15 paths through it. Yeah. So my approach is often obviously you start breaking that code down, right? Mm-hmm. And then people get worried about abstraction and thinking, as I break this code down, are these things going to live in the right place? Can I develop the domain out of it and get the right classes in the right place?
Sure, yeah.
I would say often, don't worry about that stuff too much. Mm-hmm. Don't get lost in the weeds of trying to, do that.
Okay.
One of the first steps is just to try and simplify the code and get some tests there. Mm. And I think often it's, if you've got an interface method with loads of code in it, mm-hmm. and we've all seen these methods, that you just hold your head in your hands every time you sort of see them. But I think just break the code down into some simpler private methods and call them from the main public interface.
Okay.
And you can write tests for private methods. There's no problem with that.
Right.
Just make sure that those small pieces of logic work as expected.
Right.
And then hopefully you're just beginning to break it down. And, obviously with a legacy application, I think to move away from legacy, you have to probably do 2 or 3 rewrites anyway.
Agreed.
Your first kind of rewrite is often understanding the code and just trying to break it down a bit. Mm-hmm. And then you can start going, okay, so this code has got some tests now, understand it a bit better. Now I'm going to think about the thorny topic of abstraction and good code design. That's the difficult stuff. That's when you need to hire the really clever people cleverer than me, It's, but yeah, so I'd say always as a first step, keep it simple. Just try and break those sort of logic gates down into their own small little testable functions, and then you can move forward.
I see. Yeah. Legacy code is all around us, and we can't seem to get away from it, or at least I can't. And it is extremely challenging when you're testing on a legacy app, something that you haven't necessarily built or aware of. You assume that it works, and half the time it doesn't. There is perhaps no budget for improving what already exists and is already quote unquote acceptable. Now you've got, and just touching upon that, you've got a management background, because you once managed a team of developers. Is that right?
Yeah, so I did up until midway through last year. I was head of tech at an agency in London, and I did that for about 2.5 years.
Right.
Yeah, there's a whole life story thing that I'm going through at the moment that sort of links to that, but I won't bore you with that. But I did that for 2.5 years, and obviously before that, as I touched on with the sort of CNN story, I had run my own business for a couple of years as well, sort of startup. So
okay.
I do seem to have a sort of understanding of sort of the wider financial businessy side of stuff. What a lot of developers might see as the sort of airy-fairy stuff of software development.
Well, that's a very important thing to be aware of. It's to understand the business needs from that standpoint. I just wonder if you've got any advice on approaching a manager, a team stakeholder, someone who owns the product, who is non-technical, to get them on board with testing, because testing is something that does take a lot of time. It takes even more time if you're working on a legacy application that is perhaps kind of already working in the sense that, you know, the boss can refresh the page and the page is there. He's obviously, or she's obviously not going to see the code. So from someone who's just coming on to take on this legacy thing, have you got any advice on what that developer could suggest or talk about to the manager who's perhaps a little less comfortable with adding more development man days to test code?
So I think it's in general terms, like when you're discussing these things with non-technical managers, keep away from talking about code too much. Don't talk about code,
right?
Because that's not what they want to talk about.
No.
Often what it is taking your understanding of the problem in a code sense and turning it into a language that they understand.
Right.
Okay?
Right.
And two of the topics that are often good if you want to get good reaction is obviously talk about money and finance, and talk about reputation. Okay. And in terms of code quality and testing, obviously poor code, it has financial costs. And obviously it can have reputational costs if it's not secure, or some major bug causes a major hiccup and takes it offline for a day or so. You know, so it's often, if you talk about things like that, the topics of finance, the money and reputation and things like that, that will get more attention than rather going into the nuances of code design and things, and, you know, encapsulation or anything else like that. That's not going to grab them. I think, So, because the key back to your core question is sort of like, what is the financial justification for doing more work up front than, you know, just trying to release it as soon as possible. And I have this sort of concept in my head that I've been playing with for a while, which is this sort of law of minimum cost, right? That basically every software development task has a minimum cost associated with it, and you can't get below that minimum cost. The only thing you can decide on is when you're going to pay for it. So are you going to pay for it now, or are you going to pay for it later? So the justification for testing financially is that you get as much of the cost prior to production release as possible, right?
Okay, yeah,
because if you don't do testing, or you don't do testing well, and then you release code, you're going to have a whole bunch of issues to fix later. And that's where your costs will begin to spiral, and they spiral in a couple of ways. One is that you have to obviously start fixing bugs. Right. So your developers lose focus maybe on releasing the next big feature. They're focused on like fixing bugs now. So their efficiency goes down. Right. They're most likely dealing with a lower code quality. Yeah. So again, it takes them longer to do things. And there's that cost. And then you get all these side effect costs, right? So all these side effect costs are like when you start putting bad code into production. Say, for instance, your tool is for an internal part of your company. So other people within your company need this software to produce something that goes online and yada yada. Now, if that is of a poor quality and has been poorly designed and is inefficient, that's going to cause costs to rise in their team. Yeah. 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 The problem often is those costs are untracked because businesses aren't making the financial connection between this inefficient team over here.
That is so true. Yeah.
and then you've got the user issue. So if your site is very focused or application is very user centric, like as in has lots of users using it, and Google have done loads of research on this to prove this is the case in terms of site performance and speed.
Yeah.
If you've got a buggy system and there are bugs hidden there, guaranteed if you've got enough users, they will start finding those bugs, and you could be losing 10 or 5% of revenue because users just have this buggy experience and drop out before conversion, before they hand some money over, they spend less time on your site because it's all those things. And I think when you have that sort of conversation with someone who's non-technical, like a product owner maybe, or someone in the finance department or various other places, they get that. They start to understand what you're saying to them. They go, okay, so what you're saying to me is if we do testing, it might cost us a bit more upfront, but it will keep our long-term costs down. And that's the financial argument there. There's also the reputational thing that, bugs can be very damaging to your reputation. We've all seen things with Apple and Facebook and various other companies that are sort of bug related.
Yeah. And also, I guess I totally agree. That was such a nice way of describing that to a non-technical person. In the past, I have, because some of these stakeholders like graphs and charts and numbers, one number is bigger than another number, so that must mean something, right? So in the past, what I've done is analyzed legacy code. And I haven't gone in with the intention of scaring them, but I've gone in and just said, look, this is the number of lines of code. This is the longest function signature, and that isn't tested. As in, I don't know what happens with that, and I need to write code onto that, and that is a pain point for me. So it's difficult because I don't necessarily want to put my name to code that other people have written that aren't in the company anymore. Because as soon as you write code and you commit the code to someone else's code on top of someone else's code, that becomes your code. Yeah. So you are essentially taking ownership of that. And I like to, if I've got a chance to just see where the pain points might be. And I think sometimes it's always handy in the back pocket to pull out some numbers and just say, yeah, this is what I got to work with. I did a project recently where it was a horrendous legacy system. It was nuts. And we had methods that were 15, 20 parameters in terms of the signature. It was crazy. And sort of refactoring that was so painful. But the thing is that the owner is not aware of this. The person who just refreshes the page and goes, yes, it's up, isn't aware of this. And so they'll just keep piling on features and features and features. And if the foundations are shaky, like, for example, we had this thing where we had to upgrade the PHP because the server was no longer supporting the old PHP version. And that just blew up with a lot of the deprecated stuff and the stuff that just was no longer working and stuff. And of course the owners were like, well, shouldn't this work? This is a cost that we never expected. So again, that's what you were talking about with the pain later on than the pain right now. It's because the developers at the time didn't have any unit tests to test that out, so there wasn't anything that I could run to reassure me. And I guess that's another point. It's sort of making it acceptable for the developer. It's sort of trying to get the developer happy with the code that they're writing upon. This is such an interesting topic because nobody likes to do more work, but we all like to work on clean code, and we all like to write clean code. And when you get given messy code, then that can be quite quite frustrating. Do you have any tips on just TDD in general, in terms of like, how do you go about writing tests before you actually delve into writing the code? Is there any sort of things that you do first of all in terms of checking for, I don't know, maybe it's different data types, or checking that the getters and setters are working? Do you test getters and setters? Is that something that you do?
Well, I do test getters. I try to avoid writing setters.
Right.
I know there are some PHP developers out there on Twitter who have very strong opinions on setters. So I don't want to upset any of them off the back of this podcast.
Right.
But I think, yeah, definitely, I will test the getter. Like, because the thing is, like, once you've got enough experience doing development, you know that there are loads of tiny little bugs that can creep in, like a spelling mistake here,
definitely.
Or you haven't properly set a property and things like that. So, like, yeah, I don't. Some developers, there are certain testers and developers who think you should only test like sort of interfaces really and like the chunky stuff, but I don't have a problem with testing a getter. I think, why not? You don't necessarily know where you're going to go with the class when you start writing it.
That's true.
So, if you start writing a test and go, okay, I probably need a getter, I'll just write a quick test just to make sure that functions and then move on. And, one of the whole points of TDD is the refactor bit, right? And like the removal of duplication and things like that. Like, I'm working on a little open source library at the moment, and I've just had a sort of realization point I hit where I've written a load of tests and I've written a few classes, and I'm like, actually, these 3 classes can be one class, you know?
Yeah.
And I will end up probably rewriting some of the tests to make that happen and get that functioning. But I'm not sure I'd have come to that conclusion if I hadn't been just writing some tests and sort of slowly working my way through the code.
Yeah.
And I think it's pacing, right?
Yeah, sure.
I think pacing is important. I think testing helps slow down your thinking and makes you think a bit more carefully about what you're doing.
Yes.
And like, you might start pursuing an avenue and go, oh, that's not quite working. These tests don't really make sense, and this code doesn't make sense. I'm going to try something else,
I guess also, like you said, it slows down your thinking. Tasks that seem really, really simple, if you do it in a TDD kind of manner, it becomes apparent that the task is actually quite difficult. It's going to be difficult regardless of whether you do TDD or not. Say, for example, just coming off the top of my head, find all users that have a certain status and send an email, that kind of thing. That task doesn't sound that difficult, but you're working with all sorts of different cogs in the wheel there. There's all sorts of things that you have to do and check to make sure that you're not sending users with the wrong status, the wrong email.
Email's one of the most dangerous parts of coding. I once screwed up email on a monumental scale. So I know full well if it's got email in it, it's like, take your time with that. Be really careful.
Can I ask what you did wrong?
I once, basically, I needed to send out an email to the user base. I think it was about maybe 100,000 people or something.
Yeah.
And what I did was I miswrote a for each loop. And what happened was the first person got one email. The second person got
I know where this
emails.
is going.
The third person got 3 emails. And basically, luckily, my MTA, my mail transfer agent on my server, basically crashed before we got beyond 1,000. But I'm pretty sure a few people probably got like 100 or 200 emails from this. And I was just like, oh my God, what an idiot. But like, it happens,
Yeah, definitely.
But it was definitely a lesson.
Yeah.
And even something as simple as send some users some emails.
Yes.
Like it's not simple.
No.
It's not the thing where developers go, oh, that'll be 5 minutes. I'll have that done by lunch. It's,
Yeah, and this goes into another topic that that I would love to talk about in more detail at some point, and that is estimating. Because when you're estimating tasks, you really should be taking into account the time it takes you to test. And there's so many unknowns there, especially if you're dealing with legacy code. If you get asked how long is it going to take you to write this functionality, and you also throw in the time to test it, then it's like, how long is a piece of string?
So I used to, when I was a manager, I used to have a process whereby my team would do their quotes themselves with their project manager, and they would come up with the timelines, and then those timelines would go through me before they went to, generally as a rule. But the team actually got quite good at this in the end. They kind of predicted my responses to things.
Okay.
But initially, I would often just add 30 or 50% to whatever they said it would take. So if they said this thing's going to be done in like a week, I'd be like, okay, probably not 5 days, we'll say 7, just to have that contingency. And like, that was something I tried to drill into my team a lot, was like, think about contingency. Think about like, this doesn't quite work out, because basically it's like a sort of a client, any form of client, whether it's internal or external. If you tell them something's going to take 2 weeks and it takes 3 weeks, they're going to be really unhappy with you. But if you tell them it's going to take 4 weeks and it only takes 3 weeks, they'll be like, great. What a good job you guys have done. And it's like this sort of, it's better to sort of try and put the bad news up front than wait until D-Day when you're like a week late. That makes sense.
That certainly does. Yeah. Very interesting stuff. Very, very interesting stuff. Before we shoot off, because I know that you're super busy, is there anything you want to discuss? Anything further? Any social media links that you want to shout out to?
I think obviously the only final thing we sort of touched on it was like, I think sometimes I think there's a big issue sometimes with how junior developers are introduced to testing, if that makes sense. And I just wanted to make the point earlier about how, like, why I focus unit tests on really simple business logic and stuff, and try to avoid things like databases and file systems. I take that approach, and I encourage junior developers to take that approach, because it makes testing so much easier. And often I've seen in the industry that a junior developer gets exposed to testing on some sort of massive legacy thing that's calling the database 3 times and then doing all this other stuff. And they're like, oh, testing's really hard. Like, oh, I don't like testing. Testing's hard. I don't want to do it. And in many respects, like, if you get, you start with testing, you do it in the right way, it's really easy, and it brings so much benefit to your code and your work and everything you do that, like, I think it's really important to introduce juniors to testing in the right way. And
I definitely agree.
It simple for them is the best way to do that. I
definitely agree. There is so much of this thinking that testing should be done after the code is written, or testing is what only pros do, or people who have lots of time on their hands. But it should be baked in at a very junior level, like you say, that testing is required. If someone was to quote some work, that work needs to come with testing inbuilt with it. You don't. I had a conversation with someone. I'm definitely not going to name names, but I asked for a quote on something from myself, and then I said, well, I double checked. Does this come with testing? And they said, oh, well, if you want the code tested, then you're gonna I'll charge you more. And it's like, well, what? So what? You're going to give me code that you've written that you haven't tested, and I'm just going to assume it works? Like, where does that? Because what happened was he wrote the quote, and he didn't think about testing. That wasn't where he started from. He just wrote the quote, and then I said, well, I guess that's going to come with unit tests and everything. And he was like, no.
No, yeah. But like, imagine doing that with a car. Like,
I know, right?
buying your Ford and Ford going, you have two options. You have the car that works and is tested, and the car where like, well, it's $5,000 cheaper, but who knows if it works?
Who knows if it might self-combust?
Yeah, exactly. Like, no one's going to buy that car. But in software development, we seem to have this thing where it's okay to buy the untested car.
Yeah.
It's a bit weird.
Yeah, right. Well, it was a pleasure speaking to you, Rob. It was really, really good. Really interesting topic about testing. Do you have a Twitter handle that you want to mention or anything that you want to shout out to? Yeah,
I mean, if anyone watching this or listening to this strongly disagrees with me, they can obviously drop me a message at Rob D. Waller on Twitter. Quite happy to discuss it further. And yeah, that would be it. Yeah, absolutely.
Excellent. Well, I'll leave those links in the show notes and I'll put them on the screen here as well. But thanks ever so much for everyone who's listening on the podcasts, watching on the YouTubes. Happy coding, everyone. I'll see you again soon. Cheers. Bye.